Good morning, guys. So today's lesson is about combining, that means bringing shapes together, and also partitioning. Do you remember what the word partition means? Partition means to cut something into parts. So combining and partitioning shapes. So it kind of combines a little bit of what we learned about polygons with fractions. And I'm going to do a quick review for you, and you guys are going to be good to go. So let's take a look at the first question. What fraction represents each part of the shape below? So these questions are easier than you think, and I want you to think of them too, like two separate questions. Okay, so looking just at the first shape, what fraction represents each part of the shape below? How many parts does the shape have? Okay, this is the basic rule for writing a fraction. Your denominator, the bottom number, is the number of parts in the whole. So how many parts are in this whole shape? 3, right? 1, 2, 3. So our denominator is 3, okay? Each part, that means each part individually, is 1/3. Okay, so the answer to this question would be 1/3. 1/3. Each part of the fraction of the shape below is represented by the fraction 1/3. Okay, same thing for the bottom question. It's just as straightforward. Really, you just have to find your denominator, which is what? 1, 2, 3, 4, 5, 6. The denominator is 6 because there are 6 parts in the whole shape. So each part is 1/6. 1/6, 1/6, and so on, right? So if the shape had 4 parts, then each part would be 1/4, or if it had 100 parts, then each part would be 1/100th. Okay, not any trickier than that. All right, let's take a look at the next type of question. This one is a little trickier for people to wrap their minds around. So it says, for the first one, and again, there's 2 questions on the page, so let's just look up here first. 1/4 of a shape is shown below. What could the whole shape look like? So this, okay, is 1/4 of a shape, right? I know it's weird to think of it, but think of it like this. This thing is 1/4 of a shape, right? So if we wanted to draw the whole shape, okay, think, how many fourths are in one whole, right? How many fourths are equal to one whole? 4 fourths, right? So if this is 1/4, we can draw out the rest of the shape. Ready? We're going to make 4 fourths. So first we have 1/4, but we want 4 fourths because that equals one whole. So we have 1/4. That would be 2 fourths, right? That would be 3 fourths. And that would be 4 fourths. 1/4, 2 fourths, 3 fourths, 4 fourths. So if this were to create a whole shape, okay, it might look like this. 1, 2, 3, 4 parts because this part is 1/4. Okay. Same kind of thing happening down here. All right. 1/3 of a shape is shown below. What could the whole shape look like? So this piece is 1/3. 1/3. Right? Even though it's cut into 4 parts, ignore that. That's just to mess with the mind a little bit. This piece is 1/3, and we want to create a whole, right? How many thirds are equal to one whole? 3 thirds, right? So if this is 1/3, we can draw out the other 2 thirds, and then we'll have 3. So we have 1/3. That would be 2 thirds, right? This is another one, 2 thirds. And then one more. That would be 3 thirds, right? 1/3, 2/3, 3/3 equals 1 whole. So this is what the whole shape would look like if we started with this piece. Okay? Very similar to this question. All right? 1/3 means you need 3 parts that look the same. 1/4 means you need 4 parts that look the same. All right, let's take a look at the last type of question you'll see. Remember these foam shapes that we played with in class? The yellow hexagon, the red trapezoid, the green triangle, and the blue rhombus. So remember you got a little bowl or a cup or whatever, and it had these shapes in it, and we laid them on top of each other, and we counted how many triangles you could fit in a hexagon, or how many triangles you could fit in a trapezoid or whatever. Okay, let's take a look at 2 examples you're going to see today. So today in your lesson, you're definitely going to see one question about how many rhombuses you can fit in a hexagon. So, if you're watching this video, look at you helping yourself out. You've probably already come across some answers, which is the whole point. If you listen to the teacher, you will learn something you need to know, right? So how many rhombuses, blue rhombuses, could we fit in the yellow hexagon? This one's always a little tricky for kids to see, but imagine you took this shape and you had foam pieces and you laid them on top. How many could you fit? That would be 1, right? That would be 2. It's just sideways. And then this piece would be 3. You can fit 3 blue rhombuses inside the yellow hexagon, which means each part would be 1/3, right? Now, what about this rhombus? What if we wanted to fit green triangles inside this? I'm sorry, I called it a rhombus. It's a trapezoid. What about this trapezoid? If we wanted to fit green triangles inside this trapezoid, how many triangles could we fit? How many of these green triangles do you think we could fit inside this trapezoid? Do you remember? 3. 1, 2, 3. So each triangle, again, is 1/3. And at the top of your lesson today, there's going to be a little reminder about how this works, because I know you don't have the foam pieces in front of you, but you kind of want to try to match the size. Like, okay, obviously my drawings are not perfect, right? But these green triangles are about the same size as this green triangle, right? Like if I had to cut this out a couple times and place it over, it would be pretty close. Same thing here with my blue rhombuses, okay? This blue rhombus is about the same size as these blue rhombuses I drew here, even though they're not perfect. Okay? That's it for today's lesson. I wish you good luck, and I'll see you tomorrow.